Hi, this is OrgoChemSimplfied, and today we're going to do an alkyne synthesis problem. So we're starting with an alkene, and in a synthesis problem, the first thing you want to do is count your carbons. So this has 1, 2, 3, 4, 5, and this alkyne with three bonds, that's a triple bond, is 1, 2, 3, 4, 5, 6 carbons. So right off the bat you know that you're going to extend your carbon chain, and the easiest way to do that is through an SN2 reaction, right? So I want to work backwards so you get to see how we can either go forward or go backwards. So we're going to start with this alkyne. We know it started with 5 and we are adding on another carbon, right? So we know alkynes can act as nucleophiles if they're deprotonated, right? So we're going to have a deprotonated alkyne here. So this is a retrosynthesis arrow. That just means you're going backwards. And it's going to be an SN2 with a carbon, a leaving group, bromide, and 3 hydrogens. Okay? Right. Now, this looks a lot closer to that. So right, before it's deprotonated, it was probably protonated. Okay. So, now here we are. How do we go from an alkene to this alkyne right here? Well, you probably can't go straight through. There's no one reaction that we know that can go straight from an alkene to an alkyne, right? So it's probably going to be a two-step, right? What reactions do we have to create more bonds? Well, the only reaction we know is elimination, right? It's E2 or E1, but in this case it's probably going to be E2. And when we do E2, you have to have a leaving group. Well, that would work if we had a leaving group here. We could go straight to the alkyne, right? But we have no leaving group here, and we want to create 2 leaving groups. If we go to the alkane with single bonds and 2 leaving groups, then we can get to the alkyne. So how do I add 2 leaving groups to the alkene? Well, we know halogens are good leaving groups, right? So all I have to do is add Br2, and that's going to add me 2 leaving groups to this alkene to give me an alkane. Now I'm going to have a Br and a Br. So the stereochemistry is going to be opposite. Okay. Now that I have 2 leaving groups, we're going to do E2 twice in one step. So one of these BRs is going to get eliminated, and that's going to give us an alkene with another BR, and another elimination step is going to take us to the alkyne. So this is going to be a strong base. I will just use LDA because it has a pKa H of 42. So that's a very strong base, right? And is this going to deprotonate the alkyne again? So how do we go to the alkyne? Add more LDA. So here we need 2 equivalents of LDA because we're eliminating 2 protons. Here we need 1 equivalent of LDA because we're taking off that proton, right? And now these 2 compounds are just going to interact by themselves. Right. So let's try to make it formal. Let's make it neater. Okay. So we're starting with the alkene. We're adding Br2. We get 2 Brs. So we have a dibromo alkane. Then we're going to add 3 equivalents of LDA. And that's going to take us to the deprotonated alkyne. Then we're going to react that with our leaving group attached to the carbon and 3 hydrogens, and that's going to bring us to our desired product. So again, in a synthesis problem, you want to do a combination of both working forward and working backwards, and that's going to bring you full circle. Just figure out what group am I starting with, what group am I ending with, did I extend the chain, what reactions do I know that can bring me from where I started to where I ended, and do I have to go through a separate step to do that. So those are the kinds of things you want to think about when you're doing a synthesis problem. Okay, so if that video helped, please like the video. If you have any comments or any questions that would help us out, please leave a comment below. I'll try to get back to you. And feel free to watch our other videos. Thank you for watching.